All right, we are going to start a unit on system of equations. And we'll start this unit by looking at solving systems by graphing. So that's where we're going to start with two lines and find out if they intersect. And if they do intersect, then what ordered pair or multiple ordered pairs would that happen in? And so for the um, introduction to this unit, a system of equations is two or more. So we have two or more equations with the same variables. And when we find a solution to the system of equations, we write that as an ordered pair. So remember that ordered pairs have parentheses. The x comes first, comma, and then the y comes second. You write ordered pairs in a parentheses. So the graphing method that we're going to use, you'll first of all need to make sure that your equation is solved for y. I circled that. That's a very important step because that lets you find the slope m and the y-intercept 0b. And then you'll be able to graph each line. When you graph each line, you're going to be looking for the ordered pair where the two lines intersect. So I tried to make that dot bigger for us. And so it looks like those two intersect at 3, 0. Now, we're not going to make you show the check, but I did want you to see how a check would work for that. So you would plug in 2 times your x value plus 2 times your y value and see if you got a true statement. So your x value was a 3 and your y value was a 0. 2 times 3 gives you 6, and 6 plus 0 does equal 6. So it checks for that equation. And then for your second equation, the blue one, the blue line, 4 times your x value plus 6 times your y value would have to equal 12. And so once again, we got 3 for our x and 0 for our y. So that would be 12 plus 0, and that equals 12. And so it checks for both. The ordered pair would have to make both equations true. So that's an introduction to the method that we're going to use. And then we have some vocabulary that we would like for you to become familiar with. And that vocabulary is used to classify systems of equations. So to classify systems of equations, I've got a table here for us to look at. If you have intersecting lines, so that would be the first line in that category, and I'm going to go ahead and just illustrate each one of these. So intersecting lines, somehow the two lines cross each other like so. Then you can know this by looking at their equations because they have different slopes. So if they have different slopes, the lines are going to intersect. And the classification that we're going to give those is that they are consistent. Consistent means that it has a solution, and independent meaning that it has two lines showing. So consistent means that they do intersect, there is a solution, and in fact, there is one solution, one point where the lines would intersect. So our next classification is where the lines coincide. Now, that's just a fancy word for saying that when you graph your first line and then you get ready to graph your second line, it ends up that they're the exact same line. So your clue that that is going to happen comes from your equations. After you've solved for y, you're going to find out that they have same slopes and same y-intercepts. So everything is exactly the same. Those are going to be consistent. So again, they do have a solution, but instead of being two lines, they're one line. They're dependent on each other. So same slope, same y-intercept. Those are consistent and dependent, and they have infinitely many solutions. Those lines are exactly the same, so they intersect at every point. And then finally, we have your third type of way that lines could show on a graph, and that would be if they are parallel. So two lines running parallel to each other. And you'll know this looking at your equations because the slopes will be the same, but the y-intercepts will be different. And so these types of lines are called inconsistent. Inconsistent. They never have a solution. They never are going to intersect. They are inconsistent. So as you go through a few of your problems, they'll be asking you about these vocabulary terms. Please refer back to this table.